Okay, a sector of a circle is basically a section of a circle. It's like the pizza, slice of pizza.
Papa John.
That's a sector. All right, we're going to find the area of the sector of the circle. Do you guys, well, let's name this first. We'll call it ACB. So what's the minor arc that we're talking about?
AB.
AB, yep, arc AB. What's the central angle?
ACB.
Yep, you can either say angle C or angle ACB. And then I'm going to have to give you a radius length. We'll call that R for now. And I'll give you the measure of the arc. So we'll call that M, and we'll put a degree symbol because I'm going to give you something for that. So to find, how do you find the area of a whole circle?
Pi r squared.
Pi r squared. So we're finding the area of the whole circle, kind of, but we need to take a part of that, or a fraction of that. You would think it's going to be minus, but we're actually going to multiply by a fraction. Because if you multiply by 1/2, what happens to the number?
It divides by 2.
But does it get larger or smaller?
Smaller.
When we multiply by a fraction or a part of something, it's going to make it smaller. So that's what we're going to do. We're going to multiply by a part of this circle. So the formula for area of a sector is pi r squared multiplied by our fraction, which will be our degrees of the circle that we're talking about, the degrees of the arc. Over how many degrees do you think?
360.
360, yep, over the full circle. With this example, we have a radius that is 3 inches, and arc AB is going to be 80 degrees. I want you guys to find the area of the sector. Okay. Should have already done that. It's a circle in here. All right. For this next part, we are going to talk about segments. Sorry. A segment of a circle. It is bounded by a chord and an arc. I'll add that in. So, area of a segment. A segment is not a line segment like we're used to. A segment of a circle, I'm going to define that. Segment of a circle means a region bounded or between, bounded by a chord and an arc. So what's in red on the circle there is an example of that. To find the area, you have to first let me draw a couple of these. Oops. Okay, in order to find the area of the segment, so if I'm looking for this area, then that would be equal to the area of the entire sector. Anyone see it yet? Minus the area of a right triangle. Okay, to find the area of this segment, we're going to start with the area of the sector. which remember is the pizza slice looking object. And so we have to use pi r squared. But what are we multiplying by?
M over 360.
Yep. So we're going to find that first.
Didn't get it.
Okay, so I recommend keeping the number without pi for this, because in a minute, we're gonna subtract this from the area of the triangle, once we have that area of the triangle. And so you don't wanna have a number with pi and a number without pi, because those are not like terms. So it's better to just have the decimal. So for area of the triangle, it's gonna be area equals 1/2 base times height. If you kind of draw out the triangle that you have, it will make a little bit more sense. We know that CB and CA are both 12. This is an isosceles triangle because those are both radii of the circle. So we have that. We also know that since this is 60 degrees, and an isosceles triangle has base angles congruent, what do the two bottom angles have to be?
60 and 60.
60 and 60. What kind of triangle does this make it?
Equilateral.
Equilateral. So what is the length of AB?
12.
In this case, it's 12. If we didn't know that, we could use trig to find that. But we're going to draw a right triangle in here. So I'm going to split that 60-degree angle, draw my right triangle, so that the length of this bottom piece of my right triangle is 6. And I'm looking for the apothem, or the height. And so I know that this little angle right here is 30 degrees now because it was half of the 60. And so we're going to use trigonometry to find the height. Since we have a right triangle now, we can also use Pythagorean theorem to find the height. So once you've calculated the area of the triangle, we end up with 62.4, and I need to subtract my two numbers for our final answer, which would be 75.36 minus 62.4, and we'll get the final area of just the green piece that we wanted. This was our segment, the area of the segment. I just want to make it clear that these triangles are not all going to be equilateral. In this case, it was because of the 60-degree central angle, and knowing that it was an isosceles triangle, it happened to be an equilateral triangle here, but it will not always be an equilateral triangle.
You just got rid of all your.
Okay, so for the arc length is this piece that is part of the full circumference. It's the distance along the arc. It's not measured in degrees. I'm giving you the degrees here so that we can actually calculate the length of the arc. But the formula is A equals 2 pi r. Then we're going to take part of that, so we do the m over 360. And when you calculate it, you get 5 pi or 15.7 feet.